Technological Progress and Growth, Chapter 12. This chapter shows how, in the long run, the growth rate of an economy is determined by the rate of technological change. It then looks at the role of research and development in generating such progress. Chapter 12 Outline, Technological Progress and Growth. 12-1, Technological Progress and the Rate of Growth. 12-2, the Determinants of Technological Progress. 12-3, Institutions, Technological Progress and Growth. 12-4, the Facts of Growth Revisited. Appendix, Constructing a Measure of Technological Progress. Technological Progress and Growth. Chapter 11 concluded that sustained growth requires technological progress. This chapter looks at the role of technological progress in growth. (12-1) Technological Progress and the Rate of Growth. Technological progress can lead to larger quantities of output for given quantities of capital and labor, better products, new products, a large variety of products. The state of technology A is a variable that tells us how much output can be produced from given amounts of capital and labor at any time. Equation 12.1 states that production depends on capital and on labor multiplied by the state of technology. So AN is the amount of effective labor. If the state of technology A doubles, it is as if the economy had twice as many workers. (12-1) Technological Progress and the Rate of Growth. With constant returns to scale and a given state of technology A, if the amounts of capital and labor change by X times, output changes by X times. If X is equal to 1 over AN, output per effective worker, Y over AN, is a function of capital per effective worker, K over AN, as shown by equation 12.2. (12-1) Technological Progress and the Rate of Growth. Figure 12-1 shows output per effective worker versus capital per effective worker. Because of decreasing returns to capital, increases in capital per effective worker lead to smaller and smaller increases in output per effective worker. (12-1) Technological Progress and the Rate of Growth. Recall from Chapter 11. Investment is equal to savings, which is a constant fraction S of output Y, so that equation 12.2 becomes lower curve in figure 12-2 shown on next slide when we divide both sides by AN to get investment per effective worker. I over AN is equal to S times Y over AN. Replacing Y over AN by its equivalent term, function of K over AN, from equation 12.2 we get I over AN equals S times a function of K over AN. The line in figure 12-2 shows the level of investment per effective worker needed to maintain a given level of capital per effective worker because I equals delta plus GA plus GN times K, where delta is the capital depreciation rate, GA is the rate of technological progress, and GN is the rate of population growth. Dividing both sides by AN, we get investment per effective worker needed to maintain a given level of capital per effective worker as I over AN equals delta plus GA plus GN times K over AN, represented by the upward sloping line in figure 12.2-2 on the next slide. (12-1) Technological Progress and the Rate of Growth. Figure 12-2. The dynamics of capital per effective worker and output per effective worker. Capital per effective worker and output per effective worker converge to constant values in the long run equal to K over AN star and Y over AN star respectively. If initial level of capital per effective worker was K over AN 0, then actual investment per effective worker AC would be greater than investment required to keep capital per effective worker at that level. Thus, capital per effective worker will increase till it reaches K over AN star. (12-1) Technological progress and the rate of growth. The steady state of the economy is such that capital per effective worker and output per effective worker are constant and equal to K over AN star and Y over AN star respectively. When the economy is in steady state, growth of output per effective worker is 0. Growth rate per effective worker would be given by GY minus the sum of GA and GN. In steady state, when this term is set equal to 0, we get the result that output is growing at the same rate as the rate of growth of population plus the rate of growth of technological progress, which is GA plus GN. By implication, the growth rate of output is independent of the saving rate. The growth rate of output is GA plus GN, so the growth rate of output per worker is GA. In other words, when the economy is in the steady state, output per worker grows at the rate of technological progress. In the steady state, output and the two inputs, capital and effective labor, grow in balance at the same rate. (12-1) Technological progress and the rate of growth. Table 12-1 shows the characteristics of balanced growth. In the steady state, capital per effective worker and output per effective worker are constant. Their growth rate is 0. As shown on the last slide, since the growth rate of output is GA plus GN, so the growth rate of output per worker is GA. Similarly, when growth rate of capital per effective worker is set to 0, that is, growth rate of capital minus the sum of the growth rate of population and the rate of technological progress, GA plus GN, is set to 0, it gives us the growth rate of capital being equal to GA plus GN. That implies capital per worker and output per worker are growing at the rate of technological progress. Or, in terms of labor, capital, and output, labor is growing at the rate of population growth, GN. Capital and output are growing at a rate equal to the sum of population growth and the rate of technological progress, GA plus GN. (12-1) Technological progress and the rate of growth. Let us summarize what we just learned. On the balanced growth path, steady state or long run, capital per effective worker and output per effective worker are constant. Capital per worker and output per worker are growing at the rate of technological progress. Capital and output are growing at a rate equal to the sum of population growth and the rate of technological progress. (12-1) Technological progress and the rate of growth. Figure 12-3 shows the effects of an increase in the saving rate. 1. An increase in the saving rate leads to an increase in the steady state levels of output per effective worker and capital per effective worker. An increase in the saving rate is shown by an upward shift of the investment per effective worker curve shown by the arrow pointing up. The new steady state level of capital per effective worker and output per effective worker are higher, given by the point where the new investment per effective worker and the investment needed to maintain capital per effective worker constant curve, red line on graph, intersect. (12-1) Technological progress and the rate of growth. Figure 12-4 shows the effects of an increase in the saving rate. 2. The increase in the saving rate leads to higher growth until the economy reaches its new, higher, balanced growth path. (12-2) The determinants of technological progress. Most technological progress is the outcome of firms' research and development, R&D activities. The level of R&D spending depends not only on the fertility of research, how spending on R&D translates into new ideas and new products, but also on the appropriability of research results, the extent to which firms can benefit from the results of their own R&D. Patents give a firm that has discovered a new product the right to exclude anyone else from the production or use of that product for some time. This increases the appropriability of research results. Focus: the diffusion of new technology, hybrid corn. Technological progress depends on how quickly new technologies are adopted in the economy. Figure 1 shows percentage of total corn acreage planted with hybrid seed. Selected U.S. states 1932 to 1956. Each state's speed of adopting hybrid corn, which increased the corn yield up to 20%, was a function of its profitability. Iowa was the first state to adopt hybrid corn, and the new technology diffused quickly. Other states adopted the new technology much later, and the rate of diffusion was slower. Focus: management practices, another dimension of technological progress. Some researchers believe that management practices might be stronger than many of the other factors that determine a firm's performance, including technological innovations. In a study of management practices and performance of more than 4,000 medium-sized manufacturing operations in Europe, the US, and Asia, 2 economists found that firms that used the same technology but applied good management practices performed significantly better than those that did not. 12-2. The determinants of technological progress. To sustain growth, advanced countries that are at the technology frontier must innovate. The difference between innovation and imitation explains why countries that are less technologically advanced often have poor patent protection. (12-3) Institutions, technological progress, and growth. Figure 12-5 shows protection from expropriation and GDP per person. There is a strong positive relation between the degree of protection from expropriation and the level of GDP per person. This highlights the importance of the protection of property rights. Focus: the importance of institutions, North Korea and South Korea. Figure 1 shows PPP GDP per person, North Korea and South Korea, 1950 to 1998. South Korea has provided private ownership and legal protection of private producers, while North Korea relied on central planning with no property rights for individuals. 50 years later, GDP per person was 10 times higher in South Korea. Focus: what is behind Chinese growth? Average growth of output per worker in China has increased from 2.5% between 1952 and 1977 to more than 9% since then. Unlike Central and Eastern Europe, China's state sector has declined slowly, and that decline has been more than compensated by strong private sector growth. Also, the Chinese political system did not change, and the government was able to control the pace of transition to a market economy. As property rights are still not well established and the banking system is still inefficient, the limits of Chinese growth are clear. (12-4) The facts of growth revisited. Table 12-2 shows average annual rates of growth of output per worker and technological progress in 4 rich countries since 1985. Over the period 1985 to 2014, output per worker has grown at rather similar rates across the 4 countries. Growth since 1985 has mostly come from technological progress, not from unusually high capital accumulation. 12-4, the facts of growth revisited. Table 12-3 shows average annual rate of growth of output per worker and technological progress in China, 1978 to 2011. Over the period 1978 to 1995, China was on a balanced growth path as the rate of technological progress was close to the rate of growth of output per worker. Since 1996, although growth of output per worker has remained high, the contribution of technological progress has decreased. Technological progress in China comes from productivity growth due to labor transferring from the countryside to cities and imported technology from more technologically advanced countries.